Yeah, I hope I'm recording now. So I'm going to do rate of chemical reaction. And the rate of chemical reaction, we are going to consider some factors that affect rate of chemical reaction. I'm going to first look at the definition of rate of chemical reaction. We are going to find the Maxwell-Boltzmann distribution. We are going to use that to explain some factors that affect rate of chemical reaction. And we are going to also look at the rate determining step, that we call RDS. That would have to do with the first or the orders and so on and so forth. Then I think we'll be done with this, and then we'll be solving a lot of questions using experimental forms and so on and so forth. So let's do it. So we are saying that when we talk of rate of chemical reaction, then we simply means that it's the amount of reactants consumed per unit time. The amount of reactants consumed per unit time. We are talking about a certain amount of reactants which are consumed per unit time. And so here we are talking about unit. We are talking about time factor here. So rates of chemical reaction. And so before a chemical reaction would have to occur, there should be that reactant that will emanate, or there should be a reaction between two compounds that will emanate or that will form and help us produce a product. And so the rate at which that reactants are consumed, that is what the rate at which they are used before we can be able to get the product, is what we term as rate of chemical reaction. Now we can also say that is the amount of product formed per unit time. And so we can talk about the reactants. Now when we are talking about the reactants, we are talking about the amount of reactants which are consumed per unit time. Now when we are also defining it in terms of product, we can say that is the amount of product produced per unit time. So now when we talk,
Please, I can't hear.
you can't hear me. Eh? Who else can't hear me? So we are saying that rate of chemical reaction is the amount of reactants consumed or used per unit time. That is one definition. And so before you can be able to form a product, the reactants that would have to be joining compounds together, they have to be consumed before a product can be formed. So for instance, if you want to form carbon dioxide as a product, when you are doing the carbon dioxide, what do you call it, gases or something, what we first do is we add hydrochloric acid to calcium carbonate, if I'm right, calcium carbonate, which in terms we call it the marble chips. That will give us a certain calcium chloride plus CO2. And so basically that is it. So there should be that consummation of the reactions before we can get a product. So we can define rate of chemical, and that happens within a specific time, or it happens within a time frame or within a time. So we are saying that the rate of chemical reaction is the amount of reactants consumed per unit time. The amount of reactants consumed per unit time. Now, when we can also define rate of chemical reaction in terms of uh, in terms of in terms of what do you call it, in terms of their product. And so we can also say that is the amount of product produced per unit time. And so products are produced whilst reactants are consumed. So products are produced whilst reactants are consumed. So before products can be formed, reactant must be consumed or must be used before there can be a formation of products. Basically, that's what it means. So if you want to, before you can be able to get banku, you first have to use a corn and the two doughs before you can be able to get the product, which is the banku. And so the two doughs will be consumed and you are able to get banku. Basically, that is it. And whilst they are being consumed, definitely there will be some things that will be lost, or that will be won't be around, or will be lost through it. Then from there we can be able to get a product can be formed or a product can be generated. And so that is it. So we can say that the rate of rate of chemical reaction,
My chemistry test for me, I beg.
or the rates can be defined as the amount of reactant consumed per unit time. We can also define it as the amount of product formed per unit time. That is it. So, for instance, if I have if I have A plus B is equal to is the sign like this, but I want to use equal to is equal to C, then we are saying that the rate of reaction for C, because C is produced, we assume that C is positive because it is produced, and so the rate of the reaction of C, rate is affected by time, so the rate of producing the product, or the rate at which the products are produced, will be rate which is given by R is equal to the T, D into bracket the concentration of C, all over the time, the T, and so that's the rate at which the product is formed. Looking at this, you realize that these are the reactants, these are the reactants, and this is the product, and so the rate at which the product is formed is given by R is equal to D C all over the T. Now let us also look at, and this here is positive. Now let us also look at A and B. The rate at which A is consumed can also be given as R is equal to minus A. It is consumed, so we assume that it is negative because it is consumed. And so it is minus the A, D into bracket A, or minus A all over the T. Now when we have to find for that of B, we can also say B is also consumed, so minus the B, sorry, slash the T. So that is it. I hope I've made myself clear. So R is equal to the rate at which the rate of reaction respect to C would have to be positive, because we assume that that one it appears. So this one disappears and it will be or appear to form C. Or we can say this here is formed, here is consumed, and here is produced. So that is it. So any of the reactants, when we are doing it, we give it negative. Now the negative only shows that there's a loss, or it is consumed. When it is positive, it means that it has gained, or there's a gain. So the science only shows that there's a loss and there's a gain. Basically, that is it. And so, and the rate, we say that instead of saying consume, you can say that the rate of disappearance of A, the rate of disappearance of A, that means the rate at which A is lost or consumed, that's minus the A all over the T. Then we can also that the rate of appearance of C, and the rate at which C is produced, or the rate at which C gains, is the C all over the T. Basically, that is what it means. Now, let us see if, for instance, if they are given in their moles. So let's say when we are giving something like this, giving for example A plus 4B is equal to A plus 4B is equal to 3C plus 3D. Now looking at using the mole ratios, we can see that this is 1 is to 4, 1 is to 4, which is also equal to 3 is to 3, right? So this one is 3 is to 3. Looking at the mole ratio. So let's note that the rate of A now, using this one, the rate of A will now become small r is equal to minus the A. This is only 1, so minus the A, minus the A, minus the A slash the T. Now when we want to equate it to, or let's leave it like that, when we want to do that of B, it will be 1 all over 4. So this R will be given us, the rate will be given us, take note, so it will always 1 all over 4, 1 all over this, 1 all over this, D, B, all over the T. Now, when we are doing that for C, C2B, but don't forget that B is negative. So it is a reactant. When we are doing this, that's for C, we are also going to get R is equal to 1 all over 3, 1 all over 3, d C slash dt. So that is it. So that is the rate of disappearance of A is 1/3 the rate of formation of C. And so now if you want to equate this to this, we are trying to say that if we want to equate A to this, we can simply say that means this to this, A to C or A to any of this. We can say that minus D minus the A slash dt is equal to this one. This is positive, so that will be 1 all over 3 C dt. So then we can say that the rate of disappearance of A, so the rate of disappearance of this A is 1/3 the rate of formation of C. So we can say the rate of disappearance of this is 1/3 or equivalent to 1/3 the formation of C. It's equivalent to the 1/3 the formation of C. Basically, that's what it means. That is what it means. And the sign only shows that one has gained and one has lost. So the gain will definitely be positive. The loss will be negative. So, for instance, the question reads, write expressions for the rate of the reaction. So the question reads, write expression for the rate of reaction 2n N2 5 which maps to 4 NO2 gas, that is O2. I want to write an expression for the rate of the reaction. I, the reactant, one of the product. The reactant, one of the product. So you first have to write an expression for the rate of the reactant. The rate of the reactant is this one. That is N2O5. N2O5. And so this one, writing the rate of the reactant, what you are going to do is this will be half, but it will be negative because it's a reactant. So R will give me small r will give me 1 all over 2. It's supposed to be negated, just showing that it has been consumed. D, that will be N2O5 slash dt. Now you have to write for any of one of the, what do you call it, one of the product. Then we can pick oxygen, we can pick nitrogen. And so if you are picking oxygen, we are picking oxygen, then we can see that it will be, let's pick the nitrogen, that will be 1 over 4. I don't know, it is positive, so D, NO2 this. We can also equate it to the second one, which is oxygen. The oxygen will be D, sorry, that will be D O slash dt. That is the rate of reaction. That's the rate of reaction. So instead we should write any of them. So we can write any of them, or we can write any of them according to the question. Now let us also consider the reaction 3A plus half B maps to 2C. 3A plus half B maps to 2C. If the rate of disappearance of B is 1.5 by 10 raised to the power minus 2 mole per dm negative 3.s minus 1, determine. Before I go to the question, you bear with me now. Looking at this formula, then the SI unit for the rate of reaction will be equal to, you know, this one is in concentration. This is concentration, and concentration is what? Mole per dm cube. So that will be mole per dm cube That's more per dm cube dot or divided by or per, what do you call it, per t. So if it is hours, you write hour. If it is second, you write second. So per second. So that will be the unit. So there's the time because it is per dt. So please, that is it. That is it. So let's look at the question. The question says that consider the reaction. Consider the reaction. Rate of chemical reaction is one of the simplest chemistry thing you can ever come across. If you don't understand anything, kindly let me know so that I take my time and take it through. So the question reads, consider the reaction 3A plus half B is equal to maps to 2C. If the rate of disappearance of B, so we are talking about this, the rate of disappearance or the rate at which B is consumed is, in other words, the rate at which B is consumed in the reaction is, the question is given 1.5 times 10 to the power 2. Yeah, Ruben asks times 10 to the power 2. Mole per dm.
Please, the example, where did you get the 1 out of 2? Because the
Is that this one? Are you talking about it?
yeah, yes, the question it was 2. So how did you get the 1 over 2?
What is it? Is it this you are talking about? This is a new question I'm giving you. This is a new question I'm giving you.
No, second question.
What is the second?
M205.
So, it's the same thing I did here. So when you're giving something like this, when you're writing the rate, you divide it, it will be 1 all over 4. You can see everything I'm in it. There's free C, so it will be 1 all over 3. You get it? So when you're giving 2, it will be 1 all over 2. When you're finding for the rate, it will be 1 all over 2. Then you find the rate. So when you're giving half, this will be 1 all over half. So put it at the back of your mind. That is how it's supposed to be. So R is equal to 1.5 by 10 raised to the power 2 mole per dm cube. Mole per dm cube per second. Determine A. The rate of disappearance of A. So determine A, the rate of disappearance. That this is disappearance of A. And B, determine the rate of formation of C. Rate of formation of C. So let's do this. The question says that if the rate of disappearance of B is 1.5 by 10 raised to the power negative 2. Now 10 raised to the power negative 2, please, this is negative 2 mole per dm cube per second. Determine the rate of disappearance of A. Number 2, the rate of formation of C. You've only been given the rate for for B, but we've been asked to find for that of A and that of C. And so find for that of A, then that means you have to equate them. Using your mole ratio. So we know that the rate of R will be equal to the rate of A. The rate of A is equal to, that will be minus 1 all over 3 d A all over dt is equal to equating it to that of B. That will also give you 1 all over is minus, so minus 1 all over half. So we can say maybe 0.5. But minus 1 all over half will give you, is it 2? That will give you 2. But let me still write 1 over 2 so that you won't this thing. So or 0.5. It's supposed to be here, but let me do 0.5. So the B all over the T. So we've been given this. We've been given this, the disappearance of B, and we've been asked to find for that of A. So we can equate both of them. So equating both of them using their rates, we can equate the rate of this to that of this. So this 3 of this is giving us half of this. So 1 all over minus the rate of this will be 1 all over minus 3 dt is equal to this. We are using the mole ratios. So looking at this, now the question says you should find for the rate of disappearance of A. So you are looking for the A dt. We are looking for the A dt. So looking for the A dt, what can we do? We can let the A dt stand on its own by multiplying. Already both of them are negative, so the negatives will cancel. And so then we come and get 1 all over 3 the A dt is equal to minus 1 all over half the B dt. Then we want to make A stand on its own, so we can humbly do this, but negative 1 all over 0.5 is 2. So we can get, so our next one, let me just do it step by step. Let me do it step by step, so I can do it 1 all over 3. When the class ends, you join again. 1 all over 3 d A slash dt is equal to minus is equal to this will be 2 d B slash dt. Now the question is you should find for the rate of disappearance of A. So you have to make this one stand on its own. To make this stand on its own, you just multiply this by 3, so that we come and get d A slash dt is equal to 6 d B slash dt. Now we are looking for the A, but we know that we've been given that of the B. The B is this, the rate of this is, the rate of B is this one. So we just factor this one here. So the disappearance of A will give us A slash dt is equal to 1.5, or let me do it, 6 multiplied by 1.5 times 10 to the power minus 2 mole per dm per so and so. So then you can get the rate of disappearance of A dt. What are you getting? What are you getting, please?
Sir, please. 9.0 times 10 raised to the power negative 2.
9.0 minus 2.
Minus 2. So let's not forget to add our mole per dm cube. Mole per dm cube per second. So per second. So dm cube slash so that is what you are going to get. So now you've been able to find for the appearance of A using given that of B. Now the question states that we should also find for the rate of formation of C, and so we can also use the same procedure by either equating the A we've been able to find to C, or equating still the B to C. Have you gotten it? Do you get it? So we can either equate, now we had our answer to be 9, so we can also equate A to C. Our A to C will be, or we are using A to C, that will be minus the A dt should be equal to, but A here is 1 all over 3. So minus 1 all over 3. So 1 all over 3. 1 all over 3. Should we go to that of C will be 1 all over 2. 1 all over 2. C, the C. The T. So to find for the C, we just multiply this by 2. I hope we get it. We just multiply this by 2. So we multiply that by 2, then we just find our answer. Then we substitute in the dA by this. There's some, but don't forget that we are finding for this one, so we would have to just ignore the negative, because don't forget that this one should be positive, because here's formation of C. We are forming C, so we can just ignore the negative. We are forming C, and C is positive, and this one is forming C using this one, so we can just ignore the negative. If you bring the negative, then it means that it has not been formed, it has rather disappeared, or it has lost it, or there's been a loss. So you just do away with the negative. So this one, you come and get 2 by 1. So this one will be 2 free dt. So this will be 2 3 times times the whole of the A. That's what we had. That's it. So please multiply it. 2 over 3 by 9.0 times 10 to the power minus 2. What are you getting? What are you getting?
6.0 times 10 raised to the power negative 2
so the C, the T is equal to 6.0 times 10 raised to the power minus 2. So that is it. Mole per dm, please. Let's not forget mole per dm cube per second. I hope you are fine now. Do you all get it to this point? I want to continue. Do you all get it to this point?
Yes, sir.
Okay, so let's do this one. You to do this one. Let me see if you get it. Consider the reaction. Consider the reaction 2A. Consider the reaction 2A. When it cuts, you join it. Consider the reaction 2A plus 3 all over 2. 3 all over 2B maps to C plus 3D plus 3D. Consider the reaction 2A plus 3 second, or 3 over 2D B, sorry, maps to C plus 3D. If the rate of disappearance of A, so the rate of disappearance of A, so R of A, R into bracket A, let me put it there in. R of A, rate of disappearance of A is given by 3.6 times 10 raised to the power times 10 raised to the power minus 3. That's 10 raised to the power minus 3 mole per dm. Mole per dm per second. Dm cube per second. If the rate of disappearance of A is 3.6 times 10 to the power negative 3 mole per dm per second, determine I. The rate of disappearance of B. So find the rate of disappearance of B. So find the rate of B. Rate of disappearance of B. I. Find the rate of disappearance of C and D. So find the rate of disappearance of C and D. So find C and D. Find the rate of disappearance of C and D. Find the rate of disappearance of C and D. Find the rate of disappearance of C and D. So do this for me. I will cut you joining again. You should be listening. Then we do the factors that affect rate of reaction. Then we go on. We do we go on. From there, we'll do the factors that affect rates of chemical reaction. I'm going to explain the factors using the Boltzmann's distribution. I'm going to use that. Then we talk about the order of reaction. Then we do rate determining step. Then we solve more questions. Then we are done for the day. Then we are done with rate of chemical reaction. I hope I can finish within the next 45 minutes. So we do it. From then next week we might try doing equilibrium. Have you treated equilibrium? I don't think so. We might do equilibrium or solubility, any of them. Equilibrium. So from there we do equilibrium. Then we are good to go. I'm hoping I can do equilibrium 2 next week. Finish equilibrium 2 with you next week. Then if you have time, you start a redox reaction. It follows with equilibrium. We are good to go.